Our series of discussion is about limits and continuity. We will discuss the limit concept first, then this will be followed by continuity. Up to now, we have used algebra and geometry to solve problems where things are basically staying the same or changing at the same rate. Calculus is a branch of mathematics that deals with things that are changing. Now, what are the examples of real-life applications that involve rate of change? One example is the rate of change at any point in the curve, the volume of an expanding balloon, or the acceleration of rocket ship that is changing every part of a second. Now, these are just few of the examples of real-life applications that involve rate of change. Before we move on to the limit concept, let us discuss first the tangent line problem. As you can see in this diagram, this line T is what we call the secant line because it touches 2 points in the curve, this point and this point. However, this line here is what we call the tangent line because it touches only 1 point in the curve. This line T here is tangent line, while the blue one is the secant line. To understand more on the tangent line problem that will lead to the limit concept, let us hear the explanation.
What makes a secant line a tangent line? As you can see, AB is the secant line, and then as I drag A toward B, the secant line becomes a tangent line. What I want you to observe is the value h. As h goes to 0, the secant line becomes the tangent line. And therefore, this should help you understand the limit from it. As h goes to 0, the secant line becomes a tangent line.
Okay, the video says that as h approaches 0, where h is the distance or the change of x, if given another point on the curve that forms a secant line, and that point, if we let that point approaches to this point, then that secant line becomes the tangent line. For example, y is equal to x squared, where the graph of y is equal to x squared is a parabola opening upward. Okay, then suppose we have 2 points in the curve. Let's say this point and this point. Okay, suppose the x value is equal to a, and this x value here is just x. Then we can form an ordered pair, p, a, and a squared. Why it becomes a squared? Because the given function is equal to x squared. So if we are going to substitute a to this given function, then this becomes a squared. How about this point? If our x is just x, then by substitution, the y value becomes x squared. So from here, from the 2 points in the curve, we can form a triangle, right triangle. Then this distance here is the delta y, which is the change of y. And this distance here is delta x, or the change of x. Now recall, given this right triangle, we can determine the slope of the secant line by the use of the formula. The slope of the secant line PQ is equal to the delta y over delta x. It is the change of y over delta x. Suppose delta x is equal to h. Now our delta x is the change of x, right? So this implies that x is equal to a plus delta x. Okay? By manipulation, since if we go back to the previous diagram, this is a and this is x. Okay? And the distance between a and x is delta x. Right? So by manipulation, this x here, okay, this x is actually this point A plus the distance, right? Therefore, x is equal to a plus delta x, okay? So x is equal to a plus delta x. And since we let our delta x to be h, then this becomes a plus h. Using the formula for the slope of the secant line, m sub pq is equal to delta y over delta x. Now, delta y is the change of y that is given by y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, our y sub 2 given 2 points is x squared, right? The y value. And y sub 1 is equal to a squared. Therefore, this becomes x squared minus a squared. X sub 2 minus x sub 1, x sub 2 is x, and the x sub 1 is a. Therefore, we have this formula for the slope of the secant line. Simplifying, since x is just equal to a plus h, right? By substitution, we just simply substitute a plus h in this variable x because of this one. Okay? So, since x is equal to a plus h, we just simply substitute that a plus h to x. Then this becomes quantity a plus h squared minus a squared over x, which is a plus h minus a. Then, we expand the quantity a plus h squared, which becomes a squared plus 2ah plus h squared minus a squared. Simplifying that one, this will be cancelled out, and a minus a cancel. So this becomes 2ah plus h squared over h. As you notice, h is common to every term. So we factor this out. So we come up with, this will be cancelled out because h over h is just equal to 1. So we have the slope of the secant line, PQ, is 2a plus h. Okay? That is 2a plus h, which is the slope of the secant line. Now, this is now the slope predictor formula. Okay. So, let's have a specific example. Find an equation of the tangent line to the parabola y is equal to x squared at the point 1, 1. Now, our example is just the same of the example that we have earlier. So, using the formula that we used earlier, the slope of the secant line is given by this delta y over delta x. Then, since delta y is x squared minus a squared over x minus a, and since at the point 1, 1, right? Therefore, the the x value is 1. X squared minus 1 over x minus 1. That's the 1 here. It's the specific value of our a. By factoring, we come up with quantity x plus 1 times quantity x minus 1. And since x minus 1 is common, cancel. So we have x plus 1. And since we are going to find the value, the slope of the secant line at 1, 1, so we just simply substitute the value of our x, which is 1. So this becomes 1 plus 1 is equal to 2. In other words, the slope of the secant line is equal to 2. Okay? So much for that. That is how we use the concept of the slope of the secant line. Now later, you will understand why we started that way in order to discuss the limit concept. Okay? Started with finding the slope of the secant line. Okay? Because later you will know that getting the slope of the secant line is actually the slope of the tangent line. Okay, so much for that. Thank you so much. Hope you like this video and hope you learn from this video, that is finding the slope of the secant line. Now for the next video, we will be talking limits, okay, in relation to the discussion that we have right now. Thank you and God bless.